is our first day of Trig, you'll be doing Trig from now till the end of April. No, then we'll do a little introductory calculus and then some fractal action.
Fractals!
The seniors will exit after the calculus. They'll miss the fractals. Okay, so like I said, most of this you've seen before. Today's is a whole bunch of little odds and ends and pieces of stuff. Not major problems to be worked. Just with all math, but particularly with trig, there's just basic facts and knowledge you have to have before you can actually work more advanced problems with it. So, if I was to give you a coordinate system, and I was to say, put an angle on the coordinate system, where do you actually position the angle on a coordinate system? At the origin, but where are the, does it matter where the sides of the angle go?
No.
Probably.
Well, actually we put them in what we call standard position. And yes, the angle itself is at the origin, but one side of the angle is always on the positive x-axis. So you always start an angle at the 0 degrees line. And then the second side of the angle extends outward however big we want that angle to be. So that's known as standard position. This side where the angle starts is called the initial side, which makes sense since initial means beginning. And the side where the angle ends is called the terminal side. It's where the angle terminates. Okay, now there's the question. How big can angles be? And can they be negative?
Will they just be 300?
Okay, because, alright, we call this line 0. If the angle is going straight up, that's 90. Okay, if I have a completely flat angle going across the x-axis, that would mean it's a 180 degree angle, but can it go past that? Can you have an angle bigger than 180? Yeah. You can go around, down here would be 270. Technically, when I get back to 0, it's the same thing as 360. Do I stop there? That's it? No, you can actually keep going. 90 degrees would be the same thing as 450. 180, if you take 360 plus 180, that's 540. So, yeah, your angles can just keep going around and around and around and around and around. They can get infinitely large. So angles can be as big as you like. Now, in our case, we will usually try to reduce them back, though, to between 0 and 360 because that tells us exactly where it's located. So if we get a 1,000 degree angle, we're going to go change it back into something smaller because it's easier to work with. Okay, now the question is, can you have negative angles? How do you have negative angles? If this is 0 degrees, if I want to go negative, would mean I'd have to go which way? Yeah, you go backwards. So if you have an angle that starts here and it goes backwards, yeah, it can be a negative angle. That could be a negative 50 degrees if I went backwards. So you can have angles that go around in the opposite direction, infinitely large. So angles can be of any size. Our degree is the only way we measure the size of angles.
No, we measure them in radians, don't we?
We do radians, and yes, we will be seeing radians again in this chapter. Radians are our friends.
I don't like radians.
Okay, in calculus, we never ever work a problem in degrees in calculus. If we see a degree, we change it to radians. Degrees are nice for certain things in the real world. Radians are nice for certain things in the real world. And you pick your angle based on the type of problem you're solving. So, I think it's 2 classes, and then we'll hit radian land big time. Okay, they are going to ask you then, one of the first problems on your assignment today is to deal with what are called coterminal angles. Okay, where did I just use the word terminal?
Right there.
Terminal side. So if they are coterminal,
They got two terminating sides.
yeah, they're angles that terminate at the same point. They end in the same place. They have different measures, but they actually end at the same location. If I say name me coterminal angles, I just want you to name me other angles that would end in the same spot. So they're going to give you something like, if I gave you an angle of 430 degrees, and it's going to say name the smallest positive and negative angle that are coterminal, that end in the same spot. The first question, where's 430 even go? And we should talk about this. What are the quadrant numbers? We're going to use those quadrant numbers.
Top right. 1, 2, 3, 4.
2 goes which way?
Left.
Yes.
3 down.
Down.
3,
Up.
4. Okay. So quadrants go around in the same direction our angles go around. So 430 is going to land in what quadrant?
Second.
Well, 430, we know we're going around at least 360. 360 is all the way around, so then how much more past 360
Would
is?
it actually be the fifth, or would it be just the first?
It'd be back in the first.
Would it be the fifth?
No.
Would it be the fifth?
So it'd be 360 plus a little more, but it's not going to make it up, so it's going to be up this way somewhere. Okay, so how big is that little bit of we have left? 70. So therefore, there's your coterminal angle. 70 degrees is the smallest positive coterminal angle that ends in that same location.
Actually, like
That's our answer, 70 degrees.
That is your positive answer. They also are going to ask you to name the negative angle that ends in the same spot.
290.
So starting at 0, you have to go backwards to that position. So how do you figure out how many degrees that would be? Yeah. Exactly. If you know this is 70, we know the whole circle is 360. So it would be, since it's going backwards, it would be negative 290 because you're going around in the opposite direction. So in this case, your two answers would be 70 degrees and negative 290. A simple picture will usually solve these quite fine. I have people who want to always try to think of a rule of add 360, subtract 360. Depends on how big the angle is that I give you, whether I give you a positive angle or a negative angle. Drawing a picture in Trig, if you are ever stuck in Trig, the answer to every problem is draw a picture. I'm going to say that to you many times this semester. If you're ever in doubt with a Trig problem, if you're doing the ACT and you have to deal with Trig, draw a picture.
So on the test, if we draw a picture, we'll get some points?
Possibly, yeah. In a lot of cases, drawing a picture will help it. Okay, now, one thing we kind of mentioned a little bit last year, but I didn't do a ton with, and I just realized I haven't thought about this one. What if you want to measure an angle in a smaller increment than a degree? Can you?
Minutes and seconds.
Yes. You can get angles to go smaller, and so they may write, it looks really bizarre. So if I said, you have an angle of 15 degrees, 42 minutes, and 37 seconds. Okay, first of all, how many, the little single prime is a minute. How many minutes are in a degree?
Is it 60?
It's time. It's like time, yes. 1 degree is 60 minutes. So you divide a degree up into 60 little parts.
So basically, the same many degrees an hour, you should be able to.
Yeah. And so, therefore, then, 1 minute is how many seconds? 60. Yes. It still works like time by 60.
15's like the hour, basically.
Yeah. So if you, every 15 minutes is going to be a quarter of the way through that particular degree. Okay. Why would we ever want to measure an angle that small? If you look at a protractor, a 1 degree angle on a protractor looks tiny. Why would we ever need angles that are smaller than that?
Or probably some sort of real world precision thing.
Yeah, well, the thing is, when you all look at your protractor on your piece of paper, you're probably not drawing angles that are more than the size of the angle or maybe an inch. But yeah, if you extend that little tiny angle out for miles, that by the time you extend out for miles, that little tiny angle is going to actually begin to cover a very large distance. So particularly in surveying and trying to lay out property lines and that kind of stuff, if you ever were to go to the courthouse and read the legal description of the land your family owns for your house, it'll be down to the minutes and seconds giving the exact location of how that piece of land lays out.
like latitude, longitude, like this how this is made?
Latitude and longitude, yeah, they break it down.
Is that how this is made? Like forty and something?
Yeah, it goes down degrees minutes a second, same way, yeah. That's,
Oh, now at my house, it has our exact location in degrees, minutes, and seconds.
so, you can do it. Alright, now, what I'm gonna ask you to do though, one of the things we have to do fairly frequently, well not frequently, but occasionally, if I gave you two angles in degrees, minutes, and seconds, and I said, add them together.
Is that 2 degrees? Like, is it 40 in degrees?
The 40 is, oh sorry, that's supposed to be a minute. I got degree happy. Alright, so 32 degrees, 40 minutes, 11 seconds, added to 13 degrees, 24 minutes, and 51 seconds. How do you add that together?
Well, you just add it, and if it's over 6, you just keep going.
Yeah.
Would you carry it over?
So should you start adding with the degrees, or should you start adding with the seconds? Yeah, start with the little numbers, just like we add normally. Start with your ones place. So if I add out here, I'm going to have 62 minutes. Can I have 62 minutes?
No.
That's over 60. So what? So, yeah, I would take the 60 out, I would leave 2 seconds, and I would carry it over to be 1 minute. So now, when I add those together, that's 65 minutes, okay, once again, over 60.
Wait, why did you only add one? Why didn't you add 2?
Because 60 minutes is 60 seconds is 1 minute. So here, if I have 65, I'm going to take the 60 out, I'm going to leave the 5 minutes sit here. The 60 are going to carry over and make how many degrees? It makes just 1 degree. And so if I add that up, I got 46. So I actually end up with 46 degrees, 5 minutes, and 2 seconds. So you got to think in terms of 60. That's the kicker. And one other one here, suppose I tell you, draw your little picture with an angle. That's supposed to be a right angle that I started with. Maybe not so great. A little bit of this is on your assignment, yes. Okay, if I told you that angle is 53 degrees, 12 minutes, how do you find this angle down here?
You just subtract it from 90.
You would subtract it from 90, wouldn't you? Okay, so, fine. 90 degrees minus 53 degrees, 12 minutes. Why does Shannon want to do 89 degrees in 60 minutes? Yeah, because right now, technically, this is 0 minutes out of here. I can't subtract 12 from 0. So yeah, you have to borrow a degree. So it is actually easier. When I do these problems, I just automatically start with 89 degrees, 60 minutes. I don't even bother to start with 90, because I'm going to need to be able to subtract from the 60. So 60 minus 12 is 48, so I'll have 48 minutes. 89 minus 53 is going to be 36 degrees. So I got 36 degrees, 48 minutes.
You can be optimistic all you want.
Okay, so to actually then type this one in, as we just discovered, if you're doing your 38 degrees, 41 minutes, 29 seconds, and you want that in your calculator,
So 38.69.
you can go 38. Did we all catch where to find degrees?
No.
And that's 88.
The little symbol down here pops up the box.
You hit it again.
You can go get, whoa, dude, degrees.
You can just hit the button again and it'll go all the way.
Oh, you can just hit that same button, okay. 38 degrees, what did I say, 29 minutes? 41 minutes. 41 minutes, whoops, sorry. Okay. 41, whoops, that was really, boogers.
It's been a while.
It's been a while, you're right, I don't have it memorized. So you're saying I could just hit this and, oh, excellent. But it goes,
Yeah, you have to go.
on here it is, so touchy. 41, hit it carefully. Minutes. And then 29, we're thinking,
You hit it twice.
yeah.
Hit it twice, yeah.
You just come over here, it looks like if you do the second symbol twice, so that you get 2 of them on there.
Hit control.
Control enter, I need it. We're going to want to go decimal. So it's about 38.691 bigger is that as an angle. Okay, the other thing I want you to know is how do you get it to go backwards? What if you got some decimal answer and they want you to give the answer in degrees, minutes, and seconds?
Push enter.
You don't want to have to convert it by hand. That's an ugly thing.
Enter.
Okay, so if I actually had, actually let's just do 23.56,
7.
I would need to tell it its degrees so it knows I'm working with an angle. Actually, it just thinks it's a decimal. So if I tell it I'm working in degrees and I hit enter,
Told you.
it did the same thing. What if I want it to go back? Okay, on the old calculators we had a DMS under the angle menu. DMS meant convert to degrees, minutes, and seconds. Okay, so we got to find where is that hidden on here. So you're going to hit the book key. You're going to have to, if you hit the letter D, it'll at least scroll down to the D's for you real quick. And I don't know. Oh shoot, I didn't have the formula in. I thought I had to hit enter. So I'd have to go book, degrees, minutes, seconds, enter, and it turns it back into degrees, minutes, and seconds. So if you have to, we don't do a lot of converting back and forth, so you won't have to worry about that too much. But occasionally we may need to. Okay, that's a good place.